Hello friends, welcome to Learn Positive with Pradeep Kumar. If you are watching my channel, like, share, comment, subscribe, click the bell icon. Today's subject is Strength of Materials, Unit 2, Solution for Problems on Stress and Strain Diagram, Part 14. If you want to see the previous video of this subject, please click the I button on the top of the video. It will show the playlist in both the language Tamil and English, and also I posted the other subject videos in the I button. Please watch all the videos and don't forget to subscribe. Solution for problem number 9. This is the ninth problem. So first I will read the question and then I will explain you what are they given. So the first question is the ninth question is the following observation were obtained on a mild steel specimen have a initial gauge length of 50 mm and initial diameter of 16 mm. Load at yield point is 60 kN, maximum load is 88 kN and load at fracture is 64 kN. Distance between the neck 9.2 mm and length after the fracture is 68.8 mm. Determine the yield stress, ultimate stress, nominal stress at fracture, percentage of elongation and percentage of reduction in area. These are the given, and now I am going to explain you. They are using a mild steel specimen in a UTM machine, so universal testing machine, and they are using the mild steel specimen dimension is 50 mm length and 16 mm diameter rod. So they are using the specimen, and now they are going to apply the load on that. They are getting the reading in that observation at yield point, that is yield load. It is 60 kN and the maximum load, it is ultimate load, is 88 kN. The load after fracture, so during the fracture the load was applied, it was 64 kN, and the distance between the neck, that is there was a neck formed before cracking, so that is 9.2 mm, and the length after the fracture, so length before the fracture is 50 mm and length after the fracture is 68.8 mm. And we have to find the yield stress, ultimate stress, nominal stress at fracture, percentage of elongation and percentage of reduction in area. This is the question they are given, and from the observation we have to find this. So first I am going to take the given data from the question. The first given data is length of the specimen, that is L. It is 50 mm and the diameter of the specimen D is 16 mm, and load at yield point, that is a yield load, it is 60 kN. I am going to convert the kilonewton into Newton. So it is 60 into 10 to the power of 3 Newton, and maximum load, that is ultimate load, that is 88 kN. I am going to convert the kilonewton into Newton, that is 88 into 10 to the power of 3 Newton. Next, load at fracture, that is a fracture load, 64 kN. So now I am going to convert kilonewton into Newton, 64 into 10 to the power of 3 Newton. And the distance between the neck, that is neck diameter DO, that is 9.2 mm, and length after fracture, that is LO, 68.8 mm. These are the given data given in the question, and now I am going to take the to find. So to find, there is a 5 things we have to find. First one is yield stress, second one is ultimate stress, third one is nominal stress at fracture, and fourth one is percentage of elongation, and fifth one is percentage of reduction in area. Now I am going to write the solution. Yield stress, formula of yield stress is load by area. Actually the formula of stress is load by area. For the yield stress I am going to take yield load by area. So I don't know the area, so I am going to find the area first. The formula of area is pi by 4 into d square. I know the value of d square, I know the value of t. I am going to substitute that value. Pi by 4 into 16 square, the value of area is 201.06 mm square. Now I am going to apply the area, value of area in the formula, yield stress formula. So yield stress equal to yield load divided by area. Yield load is 60 into 10 to the power of 3 divided by area is 201.06. The value is 298.42 Newton per mm square. And then next one is ultimate stress. ultimate stress equal to maximum load by area or ultimate load by area. Now I am going to substitute the value of maximum load. It is 88 into 10 to the power of 3 and the value of area is 201.06. Now the total value is 473.680 Newton per mm square. The next one we have to find is nominal stress after the fracture, PF. So that is nominal stress after the fracture, that is fracture load divided by area. We know the fracture load, that is 64 into 10 to the power of 3 Newton divided by area is 201.06. The total value will be 318.31 Newton per mm square. The next one we are going to find is percentage of elongation. The formula of percentage of elongation is length after fraction minus original length divided by original length into 100. So this is the formula, LO minus L divided by L into 100. The value of LO is 68.8 minus original length L is 50 divided by 50 into 100. So 18.8 divided by 50 into 100, the total value is 37.6 percentage. So now we found the value of percentage of elongation. The next we have to find is percentage of reduction in area. The formula of percentage of reduction in area is original area minus area after the fraction divided by original area into 100. So the original area, we know the original area, but we don't know the area of fraction, area after the fraction. That is we are using here a neck for neck diameter. So I forgot to put the value, put the AO. So the formula is pi by 4 into DO square. I know the value of DO. Now I am going to substitute that pi by 4 into 9.2 square. The value of area after fraction, that is AO. AO is 66.48. Now I am going to substitute the value of AO in the formula. So 201.06 minus 66.48 divided by 201.06 into 100. The value will be 134.58 divided by 201.06 into 100. The total value is 66.94 percentage. Now we found all five of them: yield stress, ultimate stress, nominal stress, percentage of elongation and percentage of reduction in area. Now I am going to write the result. So the result is yield stress, that is 298.42 Newton per mm square, and ultimate stress 473.680 Newton per mm square, and the nominal stress at fracture is 318.31 Newton per mm square. The percentage of elongation is 37.6 percentage and the percentage of reduction in area is 66.94 percentage. So these are the values we are found. And friends, if you like this video, give a thumbs up, like, share, comment. Don't forget to subscribe. Thank you friends.